Hello, Colombo. It's too light outside, but I can't see this audience that much, but that's okay. Um, Today, we're going to be talking about setting sail with Compose Multiplatform. Now, I kind of hit the title a little bit. It's actually about how to navigate with Compose Multiplatform. So let's get into it. My name is Isuru Rajapakse. You saw that video right before that. I'm an Android developer at Motorola Solutions. We make public safety solutions. So we make apps for police officers, paramedics, firefighters, and any other public safety agency out there. Our solutions are mostly in Australia. That's where my team is from. But we also have clients pretty much worldwide. All right, let's do a quick interactive session, I guess. I want to have a quick show of hands. So who's using Android? All right, we got a few people. Who's using iOS? All right, half and half, I'd say. Makes sense. Let's actually get down to the tech now. Who's using Jetpack Compose or making apps for Android natively? No one? And I'm assuming the same is true for Compose Multiplatform. Yeah, we got one. Yay. And who's here is super confused as to what these technologies even are? Yeah? Right, so let's actually learn about these technologies. Or let's learn about these terms, I guess. So Jetpack Compose is Google's a native Android development toolkit. What that lets you do is it lets you write some code that looks like that and gives you UI that looks like that. Everyone on board? Yeah. It also has state management built right into it, so you can declare what the final state looks like, and the UI will compose itself to achieve that final state. That's actually where the name is coming from. Compose Multiplatform is a collaboration between Google and also teams at JetBrains. These are the guys who actually make Android Studio, if you ever opened up Android Studio. With Compose Multiplatform, it lets us take the same UI experience and move it to iOS, desktop, and also on the web. So what this talk is going to be about? Let me set the stage for you. Jetpack Compose has its own first-party navigation solution, and this actually comes in the form of Android X Navigation Compose artifacts. However, Compose Multiplatform doesn't really have its own first-party solution yet. So that's what we're going to be learning about, what different options we can do. So let's set the stage. Now that we know the agenda, let's actually, before that, we're going to start off learning what the actual problems of navigation, what does actual navigation actually means in an app. And once we know that problem, then we're going to go around and see what different libraries we could use to solve that problem. We're not going to use a library just because people say so. All right, let's set the agenda. Actually, let's not set the agenda. Let's see what's not going to be on the agenda. Number one, we're not going to be talking about architecture. As a developer, you can choose any of these architectures as you wish, but it's really up to the team's decision. So it's use whatever the architecture your team wants to use. Or if you're building apps alone, use whatever the architecture you want to use. It's not the responsibility of the navigation library to tell you, hey, use that architecture. Number two, the same thing goes for DI, or dependency injection. It's up to the team to decide what tool they want to use for dependency injection. Once you do, just stick with it. It's not the responsibility of the navigation library to tell you use this library for DI. All right, let's get into the boat. Now, if you haven't used Jetpack Compose and you don't even plan to use Jetpack Compose in the future, I think you still should join in on the boat and see what kind of great stuff you get into. And even if you don't use Android native development, and if you say you're using Flutter or Swift UI, I think you guys should still join in and learn about what we're doing. All right, so Navigation, what I really mean by navigation is a bunch of different problems. In an app, when users open the app, and when they go to a screen, that whole experience is essentially a navigation experience. And there's different models of different navigation solutions out there that users have to go through. And sometimes we have to put these different navigation models together to create a cohesive experience. And sometimes we go from one screen to the other screens. We have to pass data between these screens. And we have to scope certain screen to only work for certain functions. We also need to learn about how to gracefully handle certain scenarios from the system itself. So those are the 6 different problems we can take a look at today. Okay? All right. We'll start with stack navigation. Now, stack navigation is the most common sort of navigation use case in an app. So to illustrate this, let's think of a screen where we have 3 different screens. We start off on the bottom. We call this the gangway screen. And we go to the top and okay, let's skip ahead, that's fine. So here we land on this screen. This is something we call the root screen or the first screen. And the users can press that arrow button on the screen and go to the next screen. And when this happens, what's actually happening on the right here is that this is like a representation of what it looks like in the memory. Your previous screen is still in the stack, but it's not active. So what you're looking at is the deck screen. It's on top of the previous screen. Make sense? So when the users go to, actually your previous screen is still active in the backstack. And when they go to the next screen, you're essentially sandwiching another screen on top of the previous screen. At this point, when the users go back, your previous screen that you were previously on is destroyed. And when you go all the way back, you only really have one screen at a time now. All right, now that we know what we want to solve, let's actually see if we can. Actually, one more thing to note here is that in some phones, like Android phones, you don't always have like a back button that you have to press. Sometimes there's a physical back button or a gesture that users can perform to go back to a previous screen. And on the web browser, there's always like a back button. In fact, there's even a URL bar that we can type in and go anywhere you want to. All right, let's actually write this up in Compose and see how it looks like. Here I have a simple screen. To put the actual image, I'm going to write the image composable function and pass the URL or the actual image asset. That's how it looks like. Now I want a button, so let's call a button. That's how that looks like. Actually, when I do this button is going to be in the middle of the screen. That's not good. Let's actually wrap this inside of a box composable function and align it to the top so it'll be on the right spot. The next thing I want to do is I want to actually refactor this really quickly. I don't want to create a screen every time a user wants to see something. And instead, I want to reuse the same exact screen for the next subsequent slides. So what I'm going to do is I'm going to refactor, rename the gangway screen just to call it slide. And then instead of handling the event right there, I'm just going to move it to the signature itself. So whoever has to use our screen has to provide those behavior. Next, let's actually add another button. I'll call this the previous button. So you can imagine in this app, you can go forward or go backwards. Actually, when in the first screen, you don't really need to go backwards. So in that case, I want to prevent users from going to backwards here. So what I'm going to do is I'm going to make that whole parameter optional so that if you want to have a back button, if you don't provide a back button, it would be there. Let's make the next button optional too for the same reasons for the last screen. Okay, right now, this screen is always going to render the same image, right? So let's make that a parameter too. So instead of putting the image right there, I can just move it to the signature and pass it as a slot. In Compose, we call these slots. Right now that I have a reusable component, I can reuse for each of the classes or each of the screens. I can use it for the deck, which is the middle screen, and I can also use it for the crow's nest, which is the final screen. All right. Now I have all the pieces I need to put this screen together. Now it's actually it's all about writing that navigation logic. So how can we do that? So instead of using a library, let's say how hard it is going to be to write this ourselves and see if we can adopt from there. So in the ship screen, instead of, we need some sort of a representation for each node in the navigation hierarchy. So I'm going to use an enum class from Kotlin to represent that. And then I need some sort of a variable to keep reference to that value that I've chosen to represent in my stack. And then I can use that variable inside of, in this case, I'm just going to use a simple switch statement or a when statement in Kotlin to figure out what the last state is, and this, depending on which value it is, I'm going to show the actual screens. To navigate forward, all I need to do is to add that value into my list. And to navigate backwards, all I need to do is to remove that value from the list. Make sense? All right. That's one problem. The next problem is about tab navigation or page-based navigation models. And this is something also common, like if you, for instance, open up WhatsApp, you have pages of information to go through. So let's see how this works. Here, let's imagine you have a middle deck screen and a back deck and a front deck. Similar to the stack, unlike a list, you have pages existing side by side. So when the users go to the left page, the rightmost page is expected to be destroyed. And when the users go back to the middle deck, since we don't have a rightmost page, at this point, that screen is recreated. And when the users go to the right screen, the further survey screen on the left gets destroyed. That's how the page-based navigation models usually work. If we were to do this ourselves, what we would typically do is instead of containing a list of values, here we just need to contain a single value. So in my case, I'm just going to create another enum value called text screens. And here I have 3 different screens to go through. Keep a reference to a single value because we don't need to create a stack of values. And to navigate forward or backwards, all we just need to do is to just point at the value we want to go to. So while you're on the back deck, you just go to the middle deck if you press the button, and the same is true going backwards. So far, we didn't really have any actual use case for a navigation library, right? Like, why are we using navigation if we can just do all that, right, ourselves? But that assumption breaks down when it comes to using nested navigation models. So what do I mean by nested navigation models? Let's bring back the same example. So here we have the example number 1, and we want to put the example number 2 in example number 1. So you can imagine where you have a navigation hierarchy where you can go both vertically and horizontally. Make sense? So when you're on the middle deck, you can go to the left and the right as well. This is how that will look like. You have the initial vertical navigation or the stack navigation as the root navigation. And then when the users arrive on the middle screen, here we want to create another nested navigation model. And this is where you would put the other nested screens on. So when the users press the left button, it'll go to the left screen, which will destroy the further survey screen, remember? And when you press up from here, it should go up on the previous navigation hierarchy. Everyone's on board? So maybe here's a question. What should happen when you press that back button there? Should it go to the middle deck button, or should it go back to the back deck? Sometimes it might be it depends really, but the expected behavior is that you still should have the previous navigation hierarchy still retained for the users to go back. So for instance, on WhatsApp, if you're on the chat screen, if you go to one of the chat details, and if you go back from that screen, you expect to go back to the list of chat items. And when you press back, you're supposed to go back to where the users were. That's the expectation. Another thing here is that when you press the software back button, the system should already know where the back is. So it shouldn't be confusing what that actual back button is going to be about. So what changes do we need to do in order to implement that? Well, all I'm doing here is I'm going to bring the code from the example number 1, bring the code from example number 2, and put the example number 2 in example number 1, and hope for the best. Does this work? Survey says no. So the reason why this doesn't really work is because your text screen, by the time you leave this screen, it loses any variables that you had defined in the second level, right? So when your second level comes back on, it's as if it's a new or whole new screen. So how would we solve this problem? Well, let's actually use a navigation library and see how it looks like. Here, I'm going to be using Android Navigation Compose. This is the Google's recommended navigation solution for Jetpack Compose. According to that, we have to create what you call a nav controller, and that's how you do that. And then you hoist the nav controller inside of a nav host, and that's how you do that. And that's where you would typically put your root screen. And then you have to wrap your screens in this composable function. Now, this might look pretty dicey, but I'll explain how this works in a bit later. And inside of this screen, you can handle all the navigation functions. For instance, if you want to go to the next screen, you just ask the controller to go to the next text screen. And all of this is happening as strings. Let's have a quick review. It works for the nested navigation states. So when you have multiple navigation hierarchies, it'll work seamlessly, and it'll behave the way the users expect it to behave. But the problem is you have to deal with string routes. Now, I'm not going to talk about that just here, but I'll explain what that means in the next slide. And most importantly, this wouldn't work on iOS or desktop or even the web, because Android X Navigation Compose only works on Android. The next problem we're going to be solving is passing arguments or passing data between screens. To illustrate this, let's think of 2 examples where you have a ship screen and you have a wharf. You can think of these as a list and a detail screen. Like if you're going back to the WhatsApp example, a list of chats, and when you select one of the chats, it's going to go to the chat view, which is the detail screen. So here the users make a selection, and it'll expect to go to that detailed screen. In the root screen, we're going to have a list of clickable items, and the users can scroll on this list. So you can imagine a lazy user who takes forever to scroll down on this huge list of items and go to a certain item and says, I want that item. And at that point, that item is going to get selected, and we're going to use the arguments from that selection to create a new screen for the user. One thing to note here is that these selections are meant to be immutable, meaning that you're not supposed to change these arguments once the screen is initialized. And you pass this information back to the next screen, and in the next screen, they can crack open these boxes and show that information to the user. And one more important thing to point out here is that when you press this back button, the expected behavior is that you're expected to go back to the top of the list where the users were, right? If you imagine if you have 100 million messages, and if you have to go back to the previous screen and you're at the first message instead of the 100th message that you clicked, it would be a really bad user experience. So retaining that user scroll position is pretty important. And when you do go back, the previous screen is destroyed. And again, the users can go to another item and select a different chat maybe, and that is expected to create a new screen and add it to the top of the stack. let's see how Android X Navigation Compose solves this problem. Here, in order to navigate to a certain detail screen, you have to format your URL as like that. Now, that looks pretty suspicious, if you ask me. That looks very similar to how would web solutions tend to do navigation. Like, I know where this web is coming from. So in URL, on the top, we have this URL that looks like that. But on Android, we don't have an address bar. So what's up with that? Like, why are we modeling our URLs similar to the web when we don't have a URL to type on? So I don't really agree that that's the best way to model navigation. Apart from that side tangent, let's take a look at, and another thing you will have to do is to explicitly type what type of parameters to expect. And you're essentially redeclaring the same thing that you declared once again. And when you want to show that information, you need to manually deserialize that information again. This is a lot of work. So to contrast the Android X navigation solution, I'm going to talk about Decomposed Router. Now, Decomposed Router, full disclosure, I'm the library author behind this library. I just want to quickly spotlight what it can do compared to Android X Navigation Compose. So with Decomposed Router, instead of strings, you have classes to represent each node of your navigation. So in this case, I have a seed class that has 2 different points. And you can use a router. You can create a router yourself. And here, this is where you declare the root screen. You just simply initialize a list with 1 value. And then you can use routed content to hoist the state from the router. Here, you would get a screen which you can use a Kotlin switch statement to switch between different kind of views. When you want to pass some data from the screen to the next screen, you just simply pass the data as is. You don't need to convert it. You don't need to deserialize it. It's all done behind the scenes for you. And when you want to push, you just push with that screen configuration. And when you want to go out for the previous screen, you can just simply call the router.pop. Let's have a quick review. With Decomposed Router, I'd say, hey, it is completely type-safe. You're just dealing with row classes as Kotlin can express that. And it's also multi-platform. It works on iOS, desktop, and also on the web targets. And number 3, this is mostly important because I made it, so therefore it must be the best thing ever. All right, on to the final problem that we're going to be solving today. Actually, second final. It's about scoping instances. Now, to explain how this works, I want to explain, let's take an example of 2 different screens where we have a ship and an enemy screen. Here in the ship screen, we're going to be firing off a cannon, and on the enemy screen, they're going to be receiving some damage. Again, so we imagine we have a ship screen. Here we pass in a number of arguments, and this number of arguments are the number of cannonballs the ship's going to be starting off with. And we're going to keep, the problem with here is that we can't use the arguments to render the number of cannonballs because the number of cannonballs is going to change. And if you remember from before, the number of arguments that we pass in, that's immutable. We can't change that. So therefore, we're going to keep a copy of that value in the screen. We're going to load a cannonball, and when you fire it, it'll go down from 6 to 5. Looks good. And something bad happens. The user turned their device sideways. And if you've done some Android development, you'd know that this would cause something called a screen configuration change, which would destroy your whole screen and recreate it for you. And when this happens, the number of cannonballs went back from 5 to a 6, which is something the user wouldn't expect to happen. So how do we get around this? Instead of putting that number inside of the screen, we're going to put that number into its own instance. We move it over here, and that instance could be a vModel, whatever, it doesn't matter. The only thing that matters is that it's responsible in keeping that, holding that state, and can outlive the screen itself. And we're also going to not keep that object lying free around. Like if we kept that object without scoping that, it'll probably leak some memory, so we need to attach that object to that screen. So when we do more changes on the screen, it'll keep on updating that value. And when the users rotate their device, since our instance can outlive the screen, it'll outlive and maintain that state for us and accurately reflect the number of cannonballs. Now on the next screen, you have a similar scenario where you make a bunch of changes. And when in this case, I'm keeping track of the amount of damage the next ship took. So when you receive damages, when you rotate the device, you wouldn't lose that state. And when you go back, that whole screen, along with that instance, will get destroyed. Let's see how Decomposed Router can solve this problem. So here, I have a battle screen, which takes in a number of counts. And in order to scope that instance, I'm just going to call remember on route. What this function will do, it'll create that view model instance, and it'll keep that instance as long as that screen is in the backstack. And we can consume the states from the view model like that. All right, final problem that we're going to be solving. And this is about surviving process death. No, don't worry, we're not surviving death. We're just going to be surviving something called the process death. So once upon a time in Android, when users, let's say, use an app, they go open up a bunch of different screens, and they create this navigation hierarchy. And they get distracted, and they open, I don't know, TikTok or whatever, right? At this point, what would happen is that there's something scary lingering in the background, waiting for the users to leave. And when it finds the opportunity, it's going to strike, and it's going to kill your whole app for you. This process is called system-initiated process death. This is something all the Android apps has to go through in their life cycle. In order to survive this, as developers, we need to add some edge cases to gracefully store and restore state. So when the users return, if you don't handle it, when they return to your app, it's as if you opened up a new app. You might have seen this happens in some apps, like YouTube, for instance. When you open a YouTube video, you go to a call and come back, and your YouTube video is gone. And that's what happened. So you can test this scenario. So if you have access to ADB commands, you can run that command to see how it behaves. And if you have access to Android Studio, you can just kill the process right from there. So how do we handle this? Android has an internal way to handle such cases, and they call it save state handle. What this actually means is that when the app is about to die, it'll give you this container where you can put all the objects into. And when the app is coming back from death, when it's recreated, you can use the handle to repopulate your state. And with Decomposed Router, you can do something like that. Every time you create an instance, it gives you a handle to the save state handle. So you can use that handle to initialize your initial state for your view model. Okay. So we learned all about different problems in navigation, all the way from model navigation to showing where the users are in the screen, to combining them into multiple nested models, and passing arguments back and forth between screens, and scoping instances to a given screen, and all the way to learning about the process death. And that's it for the talk. I want to give special thanks for Motorola Solutions for empowering me, and they give me the time I need to work on these slides. And also thanks Akardi, he's the developer, he's the author of the Decompose library, which I'm using for my own library. And here are the slides. Go have fun. Thank you. No more questions.
Thanks a bunch, Isuru, for that amazing talk. So please come back over to the stage to accept your token of appreciation. And ladies and gentlemen, to present Isuru with the token of appreciation, we will now have over on the stage Mr. Damsara Ranasinghe, organizer here at GDG Sri Lanka. Let us give them a loud round of applause.